Hello all, my name is Aneta, this is Chemistry at Glance, and I think that's our fourth video now, or fifth, on organic equations that are needed for an AS level exam. Today we're going to work on the nucleophilic substitution. So first of all, like with the electrophilic addition, we're going to work on the name. Electrophilic, as you know, was electron loving. Nucleophilic means electron hating. So nucleophiles have way too many electrons. If they want to get rid of these electrons, they don't want them anymore. They have too many, so they like to share them or give them away. Substitution means we just have some group which substitutes the group that's already on the element. I think it's going to be best if I show you an example. So we're going to work on ethane. So we have our ethane drawn out. We also need a nucleophile. Today we're going to have an OH minus. That's a nucleophile. And OH minus you can get, for example, from the NOOH. They would go into OH minus and Na plus, and we use that OH minus here as our electrophile. It has too many electrons. It wants to donate these electrons. Sorry, I don't know why I draw ethane. It should be chloroethane. We working with halogen or alkanes. So this nucleophilic substitution is for making alcohols from halogen or alkanes. We have a halogen or alkane at the beginning. We want to make an alcohol out of it. So these are the first things you need to do. Have a nucleophile, have a halogen or alkane. Of course, carbon and chlorine are polar. Chlorine is more electron negative, so it gets a greater share of the electrons than carbon. So when carbon becomes slightly positive, it wants to gain electrons. And hello, there we have our OH minus, which is nucleophilic. It wants to donate electrons. It doesn't want them anymore. Therefore, his electrons will go into the chlorine. When carbon gets these extra electrons, it says, chlorine, I don't need you anymore. I have my electrons. You have your electrons. You can go away now. So what we've got is ethane. However, in this ethane, chloroethane, we substitute the chlorine by OH. So carbon bonded with OH, it doesn't need chlorine anymore, so chlorine becomes on its own. So what happens in this reaction? Let's go through it again to make it all crystal clear. We have a halogen or alkane. It can be any halogen. It might be Br minus, it might be Br, it might be I, whichever you get. We get a nucleophile. Don't worry, you always get a nucleophile in your question. They always tell you what nucleophile it is. It has extra electrons. Carbon becomes slightly positive because whatever the halogen will be, the bond will always be polar. The halogen will always be more electron negative than carbon. Therefore, carbon becomes slightly plus. When it becomes slightly plus, the OH minus wants to donate its electrons. It's electron hating, so it wants to get rid of these electrons. It gives them to carbon. Carbon becomes happy because it has electrons again. It's neutral again, and it doesn't need chlorine anymore, so chlorine is left on its own. However, there are a couple of reagents and conditions that you need to know for this reaction. You might be sometimes asked, to draw the mechanism, but you also may be asked to write the reagents and conditions. They're usually like 1 mark or max 2 marks questions, so it's worth knowing them for these extra little marks. So our reagent is of course sodium hydroxide. That's where we get the nucleophile from. It also has to be a reflux reaction. And this is because otherwise our products would evaporate, and we don't want them to evaporate, so we keep it at reflux. This reaction is also classified as hydrolysis, and this is because our OH- can also be substituted by H2O. In H2O, we can also get an OH- and H+, and the OH- which we can use for this reaction. What else we talk? Right. When I told you carbon, chlorine, they're always going to be polar, the halogen will always be slightly negative. And I also told you you can use either chlorine or bromine or iodine. That's correct. You can use any of them. However, iodine will react faster than bromine, and bromine will react faster than chlorine. There are 2 things which determine why iodine is the one that reacts the fastest and not chlorine. However, they go in opposition. Chlorine technically should react fastest because it's the most electronegative. That means it's going to take the most amount of electrons to itself. Therefore, carbon becomes even more positive. And if it's even more positive, that OH- will want to join to it even more. However, there's also a second route which we can follow, which is the bond strength. Chlorine is the smallest, and because it's the smallest, it will pack together very, very nicely with a carbon. So we will need a lot of energy to get them apart. Iodine is the biggest out of these 3, therefore it will very easily, with not a big amount of energy, just divide or go away from a carbon. Bond strength is it basically wins the battle between bond strength and electron negativity. Bond strength is more important in this situation, therefore we go with the fact that iodine will react the fastest out of these 3. That's all the basics you need to know for nucleophilic substitution. I included the mechanism, which you may be asked to draw. I included the conditions, reagents, and I think I included all the bits and bobs you might be asked in the exam. Of course, the example may be different, but I think the overall explanation of this organic equation is provided. If you liked my video, remember to leave the thumbs up, subscribe, share with your family, your friends, and see you soon. Bye!